Assalamualaikum and a very good day. Okay, today me and my team will present about our project which is RAM testing. I am Muhammad Amir Hisham bin Razian.
My name is Nur Amira Hani binti Azmi.
And my name is Muhammad Edi Firoz bin Abdul Razak.
My name is Ko Bung Song.
Okay, we will proceed to our introductions.
Okay, what is RAM? RAM is the hardware location in computer where the operating system, application program, and data in current use are kept so that they can be quickly reached by the computer processor. Uh, as you can see on the right side, this is the RAM that using in the laptop, but for our project, we are using the RAM in the Etherboard, which is smaller than this one. So for any system, testing play a significant role is to identify defect, the deteriorate, the quality of the system, even lead to the system failure. With the development of the sub-micro manufacture technology, a large number of memory cores are now integrated into a single chip. Okay, next, about our objective of this project. Okay, for this project, we need to test the sample RAM read errors at each speed at a rate of 50 megahertz for 214 cycle and displaying output throughout RS232 UART.
The next part, our scope is cycle through frequency from 150 MHz until 600 MHz, incrementing by 1.25 MHz. The sample RAM read the errors at each speed at the rate of 15 MHz for 2 power 14 cycles. The sample 2 tests per cycle, so actually sample 2 power 15 times. This project to show that RAM read errors at each speed rate of 15 MHz for 2 power 14 cycles. Next.
Okay, this is our project description. This is a Etherboard in system architecture. And this one is a schematic diagram that the circuit from the Etherboard.
Okay, for the conclusions, from the results taken, RAM always have its own working free range before certain errors may occur. In this project, we use three input, which is the clock input, 50 megahertz, which is 20 nanosecond, the key group input, which is 125 megahertz, and the SW group, which is 600 megahertz. In the output window, which we simulate by using simulation waveform editor, the error occurred at period 10 nanosecond, which is at half clock cycle of the program, which is it is situated at output hex 0, hex 1, and also LEDR. That three output which have the errors in the simulation. Okay, what I'm trying to say is when troubleshooting memory read errors, testing at known good timings is often advisable with the system set. RAM timings can be set for a given model or settings advised by the manufacturer on default SPD timing setting. Okay, sometimes RAM may be made to work at slower setting that are affected by hardware degradation, or it is just not performing to its specifications. So under certain circumstances, every system needs to be supervised to which is what is it because every RAM have its own specification, so they need to provide a system within the range of the RAM maybe operate. Okay, so for the conclusions, the E2 bot can prove theoretically about the memory in a RAM as a practical knowledge and also experiences. For Q&A sessions, the question is, what are the unique features of your child project? Okay, our unique features is our project may be simple, but for every system that is used, we can detect all the errors and also we can display it on the UR board. Okay, that is one. Secondly, the unique features is that we are doing this project without even using the E2 board, which is we also we use the simulation only due to the pandemic actually. Okay, next question.
Okay, for the question 2, what did you learn from doing this project? Okay, there's a lot of things that we learn. First is how to use the quarters and how to understand the coding and how to come out with the result. Because why? The first thing we as the lecturer say we skip to the CHAO subject without taking without taking
Digital design.
architecture design uh, subject. So it's quite hard for us to do this project, but we managed to learn it well and doing successful in our project. And also we learn what is RAM. Actually, there is two type of RAM. The first one is the main RAM. Main RAM is using in every kind of data, and it make quickly accessible to a microprocessor. The next one is the video RAM. Video RAM is store data that display on screen and enabling image to get display faster. Alright, that's all.
For the third question, what are the challenge to complete this project? Okay, for the first one, our 4 member doesn't have a basic in a very loud coding and a quarters. So this is some challenge to us to find the research about that coding and about the quarters. And another one is for this project is a hardware project. So actually this project must do at a lab, but as a pandemic, so we only do in the simulation. So we must to recreate or rebuild the system to make the output as our result.
For the question 4, give one sentence to summarize your project. In this project, without the basic Verilog, we face a lot of error in simulation, but at last we solved the problem and we done it successfully. Thank you.
Okay, then we will proceed to the project simulation. And for the presentation, that's all from us. Okay, thank you.
Thank you.
Thank you.
Assalamualaikum and hi. Now we proceed to our simulation. For this project, we must use the Quartus as our software for this project. Now let's see the coding for our project that we got the coding from the GitHub. So this is our coding that we get. After we use the coding, so the next step is we must compile the design. So at this point, our project was successful after compile the design. So if our coding have error, so the compile design will not progress as a successful. So the result for this we can get. So you can see our let's say ancestors summary time quest, timing analyzer, and for this project, our family for DE2 bot was a Cyclone 4E. So then we can see that circuit that built from the coding. So we go to the tools and we go to the netlist viewer and go to the RTL viewer. So this is our circuit or structure or architecture for this project. Okay. As we can see, key SW and cloud underscore 50 is as our input, and hex 0, hex 1, hex 2, hex 3, hex 4, hex 5, LEDG UR underscore TXD, and LEDR as our output for this circuit. Now we go to the another step to see the waveform for this circuit. Now to see our waveform, we go to the file and we go to the new, then we go to the verification or debugging file and we choose the university program VWF to see the waveform that we got. Okay, the first step for this, we must edit our end time. Let's say we use 40 nanosecond. Okay, then as we edit the grid size, so we take 1 nanosecond as our period for each grid. Then we go to the edit and we insert the node. Okay, so at this point we go to the node finder, so we go to the list. So as we can see, there is more input and output. So we take the input first, it's clock 50, and then key, and the last input is SW. Okay, now we take the output group. Okay, the first one we take the hex 0 and then hex 1, and then we go to the hex 2, we go to the hex 3, hex 4, hex 5, LEDG, LEDR, and the last one is our URTXD. So we click the OK, and then we click the OK right there. So for this project, our proposal say that our clock cycle is 50 MHz. So we use the override clock, so we change the 50 MHz to the period as we get, as our calculation is 20 nanosecond and the offset was 40 nanosecond. So we got this, and then for the key input, the first input that we has as a 125 MHz. So we convert to the period, we got 8 nanosecond. Then for the SW is our maximum point in this was a 600 MHz. So the value of the period is 1.667 as our period time. Okay, we got that. Now we proceed to see our product is our output for hex 0, hex 1, 2, 3, 4, 5, LEDG, LEDR, and UR. So we go to the run function simulation to run this waveform. So yes, and then yes. So we Okay, this is our output for x0. The first at the half cycle we got 1 0 0 0 0 0 0. And then we got the same output here. So as you can see, if one instruction needs one cycle to complete the instruction, but this is only needs half cycle, and then it's a change to the another instruction. So that is our error that we got from this signal. This is our observation for this project. So thank you.